Hello everyone. Today, I am going to talk about criss-cross rule. Criss-cross rule is used to deal with ionic compounds. So what is the use of criss-cross rule? Criss-cross rule is used to find out the chemical formula from the names of ionic compounds. For example, you are given the name of a compound, like sodium chloride. How can you know or deduce that NaCl is its chemical formula? In this case, we can apply criss-cross rule to find out the answer. To perform criss-cross rule, we have the following steps. First, write down the name of the compound. Second, write down the symbols and charges of elements according to the name. Remember to write the cation first. Third, apply criss-cross. Afterwards, write the charges as the subscripts. But note that the number 1 is not written. Finally, combine the results to give the chemical formula. If you don't understand what I am talking about, be confident. I am going to demonstrate the steps with some examples. Example 1 is magnesium chloride. First, write down the cation and anion. The cation is magnesium ion, and the anion is chloride ion. Then write down the symbols and charges. The symbols and charges of magnesium is Mg2+, while that of chloride is Cl-. After writing down the symbols and charges of the ions, we can apply criss-cross. Chloride ion carries one negative charge, so we write the number 1 as the subscript of Mg. And magnesium carries two positive charges, so we write the number 2 as the subscript of Cl. As mentioned above, the number 1 is not written, so the answer is MgCl2. You may wonder how I determine the charges of an ion. Then we can find the answer from the periodic table. Usually, for ions formed from group 1 atoms, they usually carry one positive charge, 1+, then 2+ for group 2 ions, and 3+ for group 3 ions. For ions formed from group 5 atoms, they usually carry 3 negative charges, 3-, then 2- for group 6 ions and 1- for group 7 ions. Okay, let us have one more example, to find out the chemical formula of aluminium oxide. Obviously, the cation is aluminium ion and the anion is oxide ion. Aluminium ion carries 3 positive charges, and oxide ion carries 2 negative charges. Then apply criss-cross. The subscript of O is 3 due to the 3+ of Al3+, while that of Al is 2 due to the 2- of O2-. Combine the results, we get Al2O3 as the chemical formula of aluminium oxide. Let's do one more drilling exercise. This time we get the name of iron 2 oxide. From the Roman numeral 2, we know that the ion carries 2 positive charges. So the cation is Fe2+, and the anion is O2-. After writing down the symbols and charges, we can apply criss-cross. We see that the subscripts of both Fe and O are 2. Meaning the ratio of units of Fe to O is 2 to 2, and we can simplify the ratio to give 1 to 1 from the mathematical perspective. When the subscripts of both Fe and O are 1, we know that the number 1 is not written. Therefore the answer is FeO. Alright, we have finished the discussions on applying criss-cross rule to find out the chemical formula of simple ionic compounds. Here we come to the second part of this video. It is about how to apply criss-cross rule to find out the chemical formula of ionic compounds containing polyatomic ions. Let's have a brief review on polyatomic ions. Polyatomic ions are ions that are composed of 2 or more atoms. Some common examples are NO3- and SO42-. In the case of NO3-, it is composed of one nitrogen atom and three oxygen atoms. It carries one negative charge overall. Therefore, it is called a polyatomic ion. We have to pay a bit more attention when writing down the chemical formula of compounds containing polyatomic ions. It is because we may have to add parentheses in the chemical formula. So when do we add parentheses? First, polyatomic ions must be present in the formula. Second, there are two or more of this polyatomic ion in the formula. The first drilling exercise is magnesium nitrate. Obviously, the cation is magnesium ion, and the anion is nitrate ion. Then write down their symbols and charges. They are Mg2+ and NO3-. Apply criss-cross. Then, the subscript of Mg is 1, and the subscript of NO3 is 2. This time we have 2 units of NO3, so we add a parenthesis before writing the subscript 2. You may ask what the problems are if the parenthesis is not added. So let's take a look what will happen if the parenthesis is not added. NO3 will become NO32, which is not understandable because such species does not exist. Finally, combine the results to give MgNO3 (2). Note that the number 1 is not written. The second drilling exercise is aluminium sulfate. We know that the cation is Al3+, and the anion is SO42-. Apply criss-cross. We will get 3 units of SO4 and 2 units of Al. So we first have Al2. Since we have more than 1 unit of SO4, we add a parenthesis before writing the subscript 3. Combine the results to get Al2, SO4, 3, as the chemical formula of aluminium sulfate. One more drilling exercise. It is ammonium nitrate. There is something special about this compound. The cation and anion in this compound are polyatomic ions. The cation is NH4+, and the anion is NO3-. After writing the symbols and charges, apply criss-cross. We see that there is 1 unit of NH4 and NO3, respectively. And the number 1 is not written. And so no parentheses are needed. The answer is NH4NO3. Okay, we have finished the discussions on applying criss-cross rule to find out the chemical formula of compounds containing polyatomic ions. If you want to learn the methods of chemical naming from a given chemical formula, you may refer to the corresponding videos.